Looks good. All right. Hi, everybody. Thanks for coming. My name's Ryan. I'm the owner at Third Coast Surf Shop. Thanks for coming out. Definitely appreciate it. This is the second in 2 years, second live workshop that we've done. So the first one I thought last October went really well, and I said to Ed, hey, let's do it again. So here we are a year later. It feels like it was just like last week. Time's flying, but appreciate everybody coming out. And we're live streaming this, so hello to everybody watching online. Ed is going to go first. He's our local surfing meteorologist. He goes by the moniker Dr. Fresh. So
Fresh water.
We've been fortunate to hook up with him and to do things like this. So we launched our new website in June, and Ed is doing the twice weekly updated surf forecast for our new website. So definitely check that out. We have some really good resources online. And then every Wednesday and Sunday we update the surf forecast for Lake Michigan. So if you don't learn much from this, then just go to that page on our website and do it the easy way. So again, my name's Ryan, owner at Third Coast Surf Shop. I want to introduce my friend Ed. He's going to go first. I'll follow him. We're going to try to keep it concise. Last year's workshop, we had one other guy, Bob Dukeshire from the National Weather Service, from NOAA, the National Oceanic Atmospheric Administration.
Got it.
He came down from Grand Rapids, so we had 3 of us last year, and the whole thing lasted 2 hours, which was really long, I thought. So Ed and I are going to try to keep it to about an hour or so, and then we can do a Q&A afterwards. So Ed, take it away.
Okay. So there's a lot of acronyms in meteorology, so a lot of things to remember. But yeah, so my kind of long story short, moved to the Great Lakes in 2011. I had been researching surfing the Great Lakes since the 1990s, and it's kind of surreal that I'm surfing with the same people that I read about when I was in middle school, never thinking I would actually meet them. So the surfing community around here is legit, and I got a degree in meteorology from Millersville University in southeastern PA, so kind of I grew up surfing the Jersey Shore. So it's amazing how many surfers are weather-wise people. Like, a lot of you already know your stuff. But there's a few things on here that could make your search a lot easier. A lot of you use a bunch of weather apps that are based off of models that are global. The resolution on them is poor, meaning there's not as much data that goes into them. So there's free tools on the internet that you could use that actually would tell you exactly when that wind shift is going to happen, exactly how strong the winds are going to be. So how many of you have like a wind finder app on your phone? Or yeah, so all that stuff, you can go much deeper than that in a real simple way. So we'll touch on that too. But first, I'm going to cover some of the meteorology of what generates waves on the Great Lakes. So we can go to the next slide. We'll start off with a little weather 101 here. So the main thing that drives, okay, what we need to produce waves is wind, and temperature differences across the planet drive differences in pressure, and that difference in pressure drives wind. So we really need that difference in pressure, especially a big difference in pressure over a small area. So the greater the pressure difference over an area, the stronger the wind, and ultimately the bigger the waves. So, and that stuff we already knew, but we're going to go a little deeper into that. So we can go to the next slide and show what's happening. I think it's just more weather 101. Yeah, so what drives waves? Wind, simply put. Okay, we can go to the next one. Thought I'd break it up with a nice picture there. Not of the Great Lakes. I think that's in New Zealand. Obviously, a good spot that gets some pretty good waves. Okay, so when I'm putting a forecast together and I'm seeing wind blowing across Lake Michigan, I'm biased towards Lake Michigan because I live on the south end. But this works for obviously all bodies of water. Fetch. So fetch is the distance wind travels over water. The greater the fetch, the better the wave. If the southern half of Lake Michigan is blowing out of the north and the northern half is blowing out of a different direction, I'm going to be much less excited. I want the whole lake blowing in the same wind direction. And much of the time, That's what happens. You know, Lake Michigan is small enough where the wind direction is the same over most of the lake. Now, sometimes that's not the case, and we'll cover that too. Obviously, the other factor that many of you look at when looking at buoys is wave height. So that wave height you see when you're at the National Buoy Data Center, that wave height you're reading is called significant wave height, which is the average height of the highest 1/3 of the waves. So that wave height you're seeing is not necessarily the highest wave that's occurring. It's the mean. It's the mean highest. It's the average highest 1/3 of the waves. And then of course the last one, that's the one I look at most. That's the one I care about the most. Wave period. It's the most overlooked variable. All my friends who surf along the East Coast, all they pay attention to is wave height. Wave period tells you how much energy is in the water. So basically the wave period is the time it takes for two wave crests to pass a fixed point, like a buoy. It gives you a good idea on the wave's energy, and this is, again, as I said, the most overlooked variable. I would much rather surf a 2-foot wave at 15 seconds than I would a 7-foot wave at 4. And we'll explain exactly why that is coming up here in another slide. So we can go to the next one. I think I'm actually going to get into it here real quick. Okay, yeah, so wind drives waves. On the Great Lakes, you ever heard of groundswell? We hear that. The East Coast of the U.S. doesn't really get groundswell that often. It's pretty uncommon. I wouldn't say it's rare, but it's uncommon. I consider groundswell, there's not a strict definition, but I consider groundswell a wave period of 13 seconds or more. We don't see that on the Great Lakes, just simply because they're too small. The West Coast, obviously, they see groundswell more often, 13, 14, 15 plus seconds. When Florence came to the East Coast a few weeks ago, we were seeing periods of 17, even 18 seconds, which is rare on the East Coast. So most of what the East Coast sees is wind swell, and that's obviously what most of what we see here on the Great Lakes. So the best areas on Lake Michigan to see the best waves over the north end and over the south end, because you have wind blowing across 300 miles of water if it's blowing out of the north. You have winds blowing across 300 miles of water if it's blowing out of the south. You see your most ocean-like conditions at the very north end of the lake and the very south end of the lake. That's not to say you can't get waves, good waves at the middle part of the lake. You can, but your most ocean-like swell is seen and observed in northern Indiana, and Illinois, and southwest Michigan, and of course up in the UP, northern parts of the lower peninsula of Michigan, and the Door Peninsula in Wisconsin. So for those of you, I know there's a lot of people live streaming, swell period, the longer the swell period, the slower the swell decays. If we see an 11-second period on the Great Lakes, that swell's going to be rolling all day, which is exactly why the south end keeps rolling over 6 to 12 hours longer than a spot maybe up in South Haven. So on a really big north, South Haven may go flat, but the very south end of the lake may keep rolling 6 to 12 hours longer, because the swell period of that wave is 10 seconds, and of course with the north wind you have the swell moving perpendicular to the southern shore of Lake Michigan. Same thing for the north end. Most ocean-like conditions occur on the west end of Erie. Mainly the islands often block a northeast, but if you're west of Cleveland, you'll see ocean-like conditions there. Also the eastern end, same case with Huron, the north end, south end, the east and west end of Ontario. Superior is so big where you can still get some ocean-like conditions at the north and south end, also the west and east end of the lake. Okay, so we can go on to the next one. So this is where wave period becomes really important. So wave period is basically the wavelength of the swell, the wavelength from distance from crest to crest over the speed. And you can see if you have a higher wave period, that's directly related to a higher wavelength. So the larger the wavelength, the longer the wave period. So let's say you guys know where 45007 is. I call it the James Bond buoy. It's out in the middle part of the lake, kind of the south central part of the lake. When that buoy's reading 2.5 feet at 10 seconds, which it rarely does, but it does occasionally, I'll be much more excited if it's reading north swell 2.5 feet at 10 seconds than I would at 6 feet at 4 seconds. And the reason why, and this graphic down here does a really good job of illustrating that, a longer period swell has a longer wavelength. And a longer period swell, most of that wave is deeper down into the water. So when that wave encounters shallow water, at 4 seconds, yeah, 6 feet is head high for many, but for many of you it's not. Let's use 5 foot wave, okay? So 5 foot wave is not head high for many people, okay? So a 5 foot wave at 4 seconds is not going to amplify at the shoreline when it encounters shallow water simply because that wave is not as deep down as a longer period wave is. Does that make sense? So a 5 foot wave at 3 or 4 seconds, which happens on the Great Lakes all the time, is not going to, the breaking wave height is going to be 5 feet or less along the shoreline. Have you ever, been out surfing and you see a really big wave headed towards you, like, wow, this is a 6 foot wave, and you paddle into it, you catch it, but it has no power. You feel like it doesn't push you at all. Well, that's the 4 second period wave. But then when you're in the water and you see a wave that's maybe 4 feet and really pushes you, has a lot of power, that's your 8 second period wave. And on the Great Lakes, sometimes you'll see some swells mixing in together. I know the last swell we had a big north, but we also had some west swell mixing in there as well. That was lingering from the night before. And the waves that weren't pushing me, that was the lingering west swell that was still in the water. That was the 3 or 4 second period stuff. What you see on the buoy is the dominant period, which is the swell with the longest period. So you may have a 2.5 foot or 3 foot wave at 9 seconds on Lake Michigan while also having a 5 foot wave at 3 seconds. And the waves that you feel that have less power, that's the smaller period swell that you're experiencing. Fortunately on the Great Lakes, the one thing we don't experience is multiple swells going on at once, because usually the wind is blowing in the same direction over the entire lake. The one thing that makes Great Lakes surfing better, condition-wise, is the fact that we don't have 4 or 5 different swells going on at once like you do in the ocean. I can tell you I've had better days on Lake Michigan than I have in New Jersey on some days simply because we have a really good south mixing in with a really junky short period east. We don't really see that on the Great Lakes. It's just one wind direction impacting the entire lake. So that being a closed body of water, that's one aspect that actually makes the conditions on the Great Lakes better some of the time. Okay, so we can go to the next one. Let's see. I have a lot of slides in here, so I don't know what's next. Okay, here's what's next. High pressure. So how many of you in here look at weather maps? Like just, okay, high pressure, low pressure, whatnot. How am I on time?
You're doing okay.
Okay. All right, so high pressure, low pressure. High pressure associated with sunshine and stability. High pressure, the air sinks. It spreads out from the center of the high, and overall the air spins clockwise around areas of high pressure. Low pressure associated with clouds, precipitation, instability. Air rises, and air often converges in towards the center of the low, which causes the air to rise, and it also spins counterclockwise. Okay, that's the northern hemisphere. Southern hemisphere, pressure systems spin the opposite way. Okay, we can go to the next one. So this is a concept I didn't really talk about in last year's seminar, but I think can really help you read a weather map a lot better if you don't already read them. So if there were no other forces in the atmosphere, okay, if the only force was pressure, air would always flow from high to low pressure. So we can click the next one. So that force of air, that force caused by air wanting to flow from higher to lower pressure is called the PGF. That's the pressure gradient force. You know, when you're in a crowded room, you like to go to a less crowded room. You want more space, right? Well, air molecules are the same way. They like to go from areas of high pressure towards areas of low pressure. So if there were no other forces acting on the wind, air would flow directly from areas of high pressure to areas of low pressure. But the Earth is spherical. It spins eastward at about 1,040 miles an hour. So in the northern hemisphere, we can go to the next one, because of the Earth's spin, we have something called Coriolis. Coriolis force deflects the wind to the right, okay? So in the northern hemisphere, you have wind flowing from high to low. Wind is deflected to the right because of Coriolis, because the Earth spins to the east. If you were to launch from a rocket from the equator towards the pole, you would go like that, because at the equator, you're moving at 1,040 miles an hour. But your speed, your linear speed, decreases as you go north. So you're actually still moving east at 1,040 miles an hour as you're being launched northward. So can you visualize that deflection to the right? Okay, that's exactly what happens with wind. So that's why we get that wind circulation around low pressure and high pressure. So we can go to the next one. There's one other force that's acting on the pressure gradient force, and that's friction. So when the wind's blowing this way, friction's acting the opposite direction. So that causes the actual wind to not blow necessarily 90 degrees to the right of the PGF, but more probably at a 45 to 60 degree angle. So now we can go to the next one. So that causes the wind to blow counterclockwise around areas of low pressure and clockwise around high pressure. Does that make sense to everyone? Okay, because I know that's a little more detailed than I normally get, but the arrows kind of blow inward towards the low, and the wind kind of blows clockwise around the high, but kind of spreads out or diverges from the center of the high. So that's basically why air spins around pressure systems the way that they do. And it's very important because obviously it plays a major role in our weather pattern, and that explanation I gave you right there is why hurricanes never develop at the equator. They always develop north and south, because Coriolis force is 0 at the equator and maximum at the poles. So you're going to get more rotation in big areas of thunderstorms the further north they are from the equator. You'll never get hurricanes crossing the equator. You always get hurricanes forming the Tropic of Cancer and the Tropic of Capricorn towards the north or south poles. Okay, so now we'll get into kind of the setups that I like to see on the Great Lakes for big waves. First one is the Canadian High. Second one is the Great Lakes Bomb, Ohio Valley Low, Clipper System, and Nor'easter. So we'll go to the Canadian High, which is what we saw on Thursday. So for those of you who were, anyone surfing on Thursday? Okay.
Yes.
So you guys were on a different lake, I assume, or you just couldn't get out? Just couldn't get out. Okay, yeah, it was.
Some people work at.
Yeah, I'm off a good chunk of I work a lot over the weekend, so I have several days off during the week, so I'm able to fortunately score it when it's good. But yeah, this is a Canadian High setup. So we have a high pressure system moving in from Canada, which has cold air, a cooler air that digs into a warmer lake. So basically, obviously, many of you have heard that colder air over a warmer lake is a perfect recipe to generate waves. Colder air sinks, and when you have colder air that's over a warm lake, especially during the fall, that cold air sinks, and the cold wind attacks the water at a sharper angle than warm air does. So the reason why cold air is better at making waves is because the angle at which it hits the water is greater than warmer air. So you have a more direct transfer of energy into the water. All waves are is a transfer of energy. It's getting that wind energy into the water, and the most efficient way to do it is with sinking air that's blowing across a water body. So we get that cold air pressing into the water at a much sharper angle than warmer air. So that's why I love to see Canadian Highs moving into Lake Michigan or Lake Superior, because we always get a really good north wind going. So this was the setup the other day, Thursday, and you can see we've got this high over here, so the wind would be blowing northwest like that. And we can go to the next one and I can illustrate that. You can see, as I showed you earlier in the pressure charts I drew, it blows roughly clockwise. Air blows roughly clockwise around the area of high pressure. So it kind of crosses the isobars at an angle. Isobars, lines of equal pressure, and those are the less bold black lines around the high. All right, we can go to the next one. So that was just the most recent setup we saw on Thursday. The next one I think is it's a Great Lakes Bomb. This is one that is really good for Superior. I'm not wild about it because it gives a west on Lake Michigan, but really good southwest for Erie, southwest for Ontario. These we see in the fall. This is the season to see these really big areas of low pressure just explode over the Great Lakes. And part of the reason why these pressure systems often deepen is because in the fall the water's still relatively warm. This was an incident back in April 17th to 19th. I think it was 2015. There is YouTube video of this event, but just incredible overhead waves along the North Shore of Minnesota. And that is the link. We don't have the internet yet, do we?
No,
Okay.
unfortunately.
Okay, but if any of you know Eric Wilkie, he's a surfer up in Lake Superior. He took this video, and I mean, it's just clean, double overhead waves along the North Shore of Minnesota. Absolutely insane. And that's what that Great Lakes bomb caused. The setup I like to see over the southern half of Lake Michigan is something called an Ohio Valley low. So that's an area of low pressure that doesn't cross the Great Lakes, it moves immediately south. And if you visualize how the wind's blowing, remember, counterclockwise around an area of low pressure, so your wind is going to be like that, out of the north. You have a high moving in, and your wind is going to be clockwise around the high, so if your wind is north, you get that correct circulation around the low and the high. Can you all see that? Okay. So yeah, so a strengthening low across the Ohio Valley, strong Canadian high out of the north. And this is kind of what you see. So on this day, June 15th, 2015, great day to surf across the south end of Lake Michigan because you had that north. I mean, I like a north-northwest anywhere from a north-northwest to a north-northeast. Becoming east-northeast as we go through the day. Okay, so yeah, we can go to the next one. Ryan, am I still good on time?
Yeah, you're doing fine.
Okay. All right. I tend to talk too much. Okay. This same system. This model right here is called the HRRR. It's HRRR. It's High Resolution Rapid Refresh, which is a model that all of you guys can use. Windfinder, the free Windfinder app that you may have doesn't use the HRRR. You have to pay for it, but you can use this model for free if you go on the NOAA website. I have links to it. This model is high resolution. It goes out to 18 hours, updates 24 hours a day. This model is really important when you want to know exactly when the wind direction is going to change. I mean, how many of you going to the beach and you thought it was going to be more east and it wasn't? The HRRR nails it almost all the time. So you got to use high resolution model data when you're planning a surf trip within 24 hours because this will often nail the change in wind direction. And it gets down to the local level on how the winds are blowing. So on this day, June 15th, I put out a forecast for Lake Erie, and I said we're going to have a major northeast swell. This is 20 to 30 knots over Lake Erie, okay? But look at the south shore of Lake Erie. Winds are offshore and light. That's because the low is moving basically directly over northern Ohio. So we had this 20 to 30 knot gale over Lake Erie. If you were to use Windfinder, it would have shown 20 to 30 knot winds along shore. But if you were to look at the HRRR, it would show light offshores for a crucial 3-hour time period during the middle part of the day. The GFS so the Windfinder runs off the GFS model, and the GFS just doesn't have as much data put into it as the more higher resolution models like the HRRR. So this shows that subtle difference in wind direction. Actually, it's a pretty pronounced change in wind direction, but it shows how the wind direction changes over a very small area, which makes or breaks a surf session, as we all know. Okay, we can go to the next one. And I think, I forget what this next one is called. All right, so Clipper system. Clipper systems are pretty good. They can move anywhere from I just picked the western Great Lakes. They can move into the eastern Great Lakes. But typically, they most of the time drop into the western Great Lakes. These aren't the best setups. They can produce some strong winds, but they're very short duration. Clipper systems move really, really fast. And they oftentimes re-intensify along the coast and generate a nor'easter. So these can create some really good events for Superior, but for Michigan, they oftentimes are too far. They often move off to the east to really make a really good swell for Michigan. And then we got the nor'easter, which oftentimes does not affect us, but some of them do. I think the last most significant nor'easter that impacted Lake Michigan was Hurricane Sandy, which was a hurricane and then became a kind of a a hybrid tropical colder system as it slammed into the New Jersey coast. So we could go to the next slide and we'll actually see the surface map. This is Hurricane Sandy. I mean, look at all those isobars.
So what kind of wind speed are we looking at with those isobars?
So here, I remember I was seeing record waves crashing over Lakeshore Avenue in Chicago.
Yeah.
So whatever that would translate to here, I was living on Lake Erie at the time, so I don't know what that would have produced here. But I mean, do you remember surfing after Sandy?
Yeah, it's rare that we get hurricane swell in the Great Lakes.
Yeah.
This is the type
That,
of thing.
I mean, yeah, that was a huge storm. If we are, you usually see hurricane type, swell come from systems that were originally hurricanes. It's going to be during the month of October and November. So this is prime season to see this kind of thing happen. I mean, most storms do not, they normally get pushed out to sea. They don't hook a west into New Jersey like Sandy did, but obviously that generated some really big swell. And I put the arrows here so that you can see the winds blowing at a slight angle to the isobars. So how many of you have been told or read that, the wind flows parallel to the isobars?
I just assume that.
Yeah, so the wind that blows parallel to the isobars is called the geostrophic wind, and most of the time the wind isn't geostrophic because of friction. Friction causes the wind to blow at a slight angle to the isobar. So if you're ever looking at a weather map, never assume, especially with the strengthening area of low pressure, the winds are going to blow more at an angle to the isobars than what you would typically see. And in some cases, when the low pressure is really intense, sometimes the wind will blow perpendicular. And that can, if you're expecting, west winds on the southern end of Lake Michigan, you could have south winds if you're dealing with a rapidly intensifying area of low pressure. But most of the time they blow at an angle, I'd say 30 to 45 degrees to the isobars, which is what that was doing. Okay, so reading buoys, this is the bookmark, favorite, all your buoy sites. I mean, when I put a forecast together, just for day-to-day weather, when I tell people what to wear the following day, the first thing I look at is current observations. Current observations lets me know what's going on right now. And buoy data tells you exactly that. What's going on in the water. One of my favorite sites. A lot of you probably go to the National Data Buoy Center, ndbc.noaa.gov. This is another website that actually gets more detailed information on what individual buoy is showing. It's called Great Lakes Buoys Gloss. Have you guys run into that at all? Okay, yeah, bookmark it. I have the links coming up here. I'll take a picture of the links and post it on the Dr. Fresh page. But yeah, so all these blue dots indicate all the buoy sites, all the gloss sites across the Great Lakes. So we can go to the next slide. And I'll show you exactly so this is the Cook Buoy. It's about 2 miles off of Bridgman. Okay, so we've got wind speed, we've got wind gust, wind direction, water temp, wave height, maximum wave height. Okay, the NDBC site doesn't give you maximum wave height. All the information that is on NDBC comes from this chart right here. So wave height, 1.1 feet. That's the significant wave height. So 1.1 feet is the mean height of the highest 1/3 of the waves. Maximum wave height is almost a foot higher than that. So when you see a buoy reading 2 feet, you're not given any idea on what those rogue sets are. When you're obviously out in the water, you'll see a rogue set come through every 3 hours, not 3 hours, hopefully, every 20 to 30 minutes. Oftentimes your maximum wave height can be reading a lot higher than what your significant wave height is. So that's not what the wave height doesn't actually tell the whole story about how big the waves are. Wave period, this is dominant wave period. You may have 3 different swells going on at once, but it's going to give the dominant wave period, which is the wave period of the swell with most energy. So it's the swell that's going to have the longest period. 2-second period, so obviously this was taken yesterday. There were no waves here. The other thing that, how many of you look at wave direction? Like mean wave direction. That's something I use all the time. For here, if we're seeing a north wind and the mean wave direction at 007, the James Bond buoy, if it's less than 45 degrees, like if it's 30 degrees or 15 degrees, that swell may not be making it where I like to go surfing in lower Michigan. So really pay attention to the mean swell direction, because if you see a good, the wind looks like it's blowing really good, if you look at the mean swell direction, that may explain why you're not seeing any waves at your spot. For me, and that I can't just tell you what wave direction works for any given location. I know it works at my spot. So a lot of it's trial and error. I know if 007 is reading less than 45 degrees, most of the swell is missing my spot. Does that make sense? So that's something you really got to pay attention to. Yeah, so if it's more than 45 degrees, I should say, it's missing my spot, because that means the wind has more east in it. And I'm mostly on the eastern side of the lake when I go surfing. So these are some of the online resources. You guys can take a picture of that with your phone. The Gloss site that I just showed you with all of the really detailed buoy information, that is, where is it? Yeah, it's right here. Buoy data. So these top two, that's the one you normally use. This one right here gives you just more buoy data than what you're used to from the NDBC site. So this one right here, glbuoys.glosgloss.us, that's the one you really want to pay attention to, because it gives you more than just significant wave height. It gives you mean wave direction, it gives you maximum wave height. I use it for upwelling. It shows you how cold the water is, 3 feet down, 6 feet down, 10 feet down, 15 feet down. Lots of interesting stuff on there. And then Wave Watch 3, a lot of you use GLERL from the Great Lakes Environmental Research Laboratory in Ann Arbor. Good site right here. You can get some Wave Watch 3 data from here, which is a really, this site is hard to navigate. So I'm pretty, at least I think I'm pretty good at answering questions when you message me privately on the Dr. Fresh page. So just do that, and I'll be able to respond to you if you have trouble navigating this. I've been using this for years, and I still have trouble getting around. Okay, so there's so many acronyms, there's so many different tabs, so I'm there. That's the whole point of the page. And of course, one of the greatest resources at the very bottom here, if you don't feel like looking at any of this, we'll consolidate it for you at thirdcoastsurfshop.com, where you can get the forecast there of everything for the next several days. So
Thanks, Ed.
yeah, you bet. All right.
A lot of the URLs that Ed used in his slide you can find on our surf forecast page at Third Coast Surf Shop. So you can take the picture and use it that way. But we also have it on the site. So everybody live streaming, just give us 1 second. We're going to switch the presentation. I'm going to talk. 1 second, please.
Will some of the other slides be put online or shared?
So we plan to, it's being live streamed, but then we'll post it to our Facebook page.
But not like the actual PowerPoint slides?
Should we just put it in a video? We could probably find a way to do that. And definitely the links for sure.
Yeah, I mean, we can get a gauge of what particular slides a lot of people find most useful. But again, I mean, message the Dr. Fresh page. I answer personal questions a lot, and I can share some of that information with you. I can share some of the slides with you and send them your way.
Yeah, we'll definitely look into. You can tell how tech savvy I am here, but I'm sure there's a way to get the PowerPoint presentation up on our site, or something like that. So we'll look into that. Cool. All right, Brianna. So Ed's the meteorologist. I'm just the surf bum. He gets deep into this stuff, and that's why he's good at doing it. So it's like if I'm unsure about something, I'm texting Ed and saying, "What do you think about this, Ed?" So I've been surfing in the Great Lakes for 20 years, and a lot of this just takes time and practice. It doesn't come easily. You can't. We don't live in San Diego. In the Great Lakes, you definitely have to put your time in. And there's so many more resources now than there used to be. When I started in 1998, it was a lot different, and we're going to talk about that a little bit. So we can go to the first slide reel. So when I started, the guys that I was surfing with were like, you gotta go to Radio Shack and buy a weather radio. I mean, the internet in 1998 was what it was. You know, there wasn't much out there. Is that working real? Here, 1 second. Sorry about this. Technical difficulties. Ah, there you go. Oh, that's not showing up.
Yeah, that should be it. There we go.
That was worth the wait, right? So you can tell how tech savvy I am. Yeah, that's me. That's how I forecast waves daily. You can go to the next one.
Hey, that's what I'm doing too.
Coffee in hand. You know. Oh, back. There you go. So maybe it's come with time, but I've gotten to the point where I can literally go on my phone and within a minute or two have a really good sense of what the waves are going to be like for the next week. And I'm going to dive straight into what the resources are that I use. They're already on our website on the surf forecasting page. The stuff Ed talks about is invaluable because that kind of sets a groundwork for knowing this kind of stuff. So when you start to, I'm not looking at frontal systems and the overall overarching scheme of what's making the waves necessarily every time. I can refer to that stuff and I have a general enough knowledge of it. But for me, just keeping it simple because every morning it's part of my routine is just going to my few apps or resources to get a sense of what's coming. And like I said, I learned on a Radio Shack weather radio is like marine forecast, 15 to 25 knots, northwest winds, waves 3 to 5 feet. It's like, I don't know if the guy was like calling in every day to the voicemail or what. These days it's, like I said, changed a lot. So for me, it's keep it simple. And another thing that's important to point out with the resources that I'm going to talk about, the further out we are from what you're seeing, the less accurate it is, right? So if it's 7 days out, you have to take it with a grain of salt. You can kind of start to say, okay, looks like next week might be something coming. 1 day out, definitely a lot more accurate. So we go to the next one.
And there's actually, I was just going to say one thing here. In the open ocean, the swell that you see is often generated from a storm that already created the waves. So you deal with a storm system that's 3,000 miles away, and it's already generated the swell, and it's not going to show up till day 6 and 7. But we have pretty good skill of forecasting that swell. In the Great Lakes, it's so weather dependent that it depends on the local winds, which, as Ryan was saying, is very difficult. Days 5, 6, and 7 out into the future. I mean, any day beyond day 7 is a marketing ploy.
So as I've already said before, we are lucky enough to have Ed doing a twice weekly surf forecast on our website. Dinosaur. That's literally the one that I bought in 1998 when the guy said, "You gotta go to Radio Shack and buy that." So I have a few tools that I use, a few resources. iWindsurf is a good one, and like I say here, I don't windsurf, but they use a model that I find useful. And again, the link, we'll find a way to get these online so you don't have to take a picture now. And there's a couple, easy steps here. You've got more of a regional overview, and you can see these boxes here. You click on one of these, it dives into a more focused, so this is the south end of Lake Michigan, our home territory. And then you can hover over any of these buoy or weather stations and then get even deeper. And I think the next one gets into that right here. So this is James Bond buoy number 45007 that Ed was talking about. It's the one, the big buoy out on the southern Lake Michigan open waters. This is what I do. Like in the morning, I've already got this on Safari on my phone. Boom, I go and I look at it. This is what they call, sorry, can you go back to that real quick? Yeah, the meteogram. It's color coded, which for someone like me, I just relate to that. You know, Bob and Ed and I kind of joked about this last year as we were preparing. And they're like, they use these color coded things and, you know, it just makes it really easy. And I'm like, yeah, you know, they think about it differently. But for me, it's simple. So the wind is showing the direction that it's blowing. And then obviously it's color coded to correspond with the strength of the wind. And here it is, you know, 5-7 days worth, right? Yes. And you know, I can look at that and say, okay, we've got a big north wind coming next week, and then each day I check it leading up to that event. I'm watching that obviously and seeing how it develops. So tool number 2 is called SailFlow. It works on the same model. The same computer model as iWindsurf.
Actually, can we go back to the previous slide real quick? There was something, and this, I didn't see this last year, but you see where it says WRF 3 kilometer? So that's the resolution. The GFS model, which just goes out to day 7, much poorer resolution. This is the model you want to use when you plan on surfing 1 to 2 days out. It's higher resolution. So WRF 3 kilometer, NAM 12 kilometer, that's the next one you want to use. When you're looking at day 4, 5, and 6, the GFS is something you can look at, but for shorter term forecast, 12 to 24 hours out, even day 2, you want to use the WRF 3 kilometer if you use this website. In the short term, at least.
Yeah, good to know.
I guess they updated that. I
learn
that was there.
something every time we do this.
Yeah. Always updating the website.
So this is SailFlow. It's the second model that I use. I'm to the point now, honestly, where I don't even have to get to this one. I look at iWindsurf, at least for like the longer term stuff, to get a sense of what's coming. The day before, day of, I will look at something like this just to get a better sense of what they're showing. And again, even though it's technically based on the same model, the same computer model, it gives kind of more of an overall look at things, and obviously you can see that here. Wind direction, wind speed, regional, focused. And then my third resource is this long gobbledygook of letters. I spell it all out here. This is a different model than iWindsurf and SailFlow. And it's the only one, or well, it's probably not the only one, but it's the main one that I use to get a sense of what the actual wave heights are going to be. So the other ones are all wind oriented. This one has wind, but it also has wave height predictions. So you can get historical data as well as experimental data. And I think I talk about that right here, yeah. So third thing I'm checking, assuming I see waves on the way, is this site going to the experimental part of it. and getting a sense of what the wave heights are going to be for a coming swell. And like Ed referred to earlier, some of these models will also nowcast and forecast surface currents, water levels, surface temps. So if we have a big offshore wind and you're wondering if the water flipped over, because sometimes when the wind blows really hard offshore, it blows that warm surface water away, it upwells the cold nearshore water, and the water temps can drop 20 degrees literally in like a day, if not less.
And just to add to that, there's other meteorologists that I know, and I explain how that wind direction, offshore winds will cause upwelling, and they're like, wow, really? But yet they'll learn that from a surfer. The meteorologist will learn from the surfer. So as I was saying, surfers are they're like farmers. They're very, very weather-wise people, and experience plays a huge role into success with finding the
Thanks,
best
Ed.
wave. Yeah. Well, no, I mean that. I'm serious.
So here's the regional overview of the Great Lakes experimental waves. And again, for us, dummies, it's color coded, it just makes it easy. They've got the key here, and then you can click through hour by hour, or you can go to the animation, which I like to do to just kind of quickly click through. And for me, just to emphasize the wave part of the equation, this is it. And of course they don't get it right all the time, but you can at least get a sense of what should be coming. Here's the focus version. So again, we're focusing on Lake Michigan primarily. I do want to emphasize, we had a question online about Lake Erie. All of the information that we're talking about tonight applies to any of the Great Lakes. We're on Lake Michigan, so that's why we're talking about it. But all of these general theories and these resources are all available for all of the Great Lakes. So you've got the resources, you're getting a sense of what's coming. This is probably the most difficult part about surfing in the Great Lakes, is trying to figure out where to go, when to be there, what it's going to be like. And I wish I could say it's easy, that we could just hand it to you on a silver platter, but it's not really. We have the tools these days to make it easier for sure, but you have to put your time in. And this is also, for me, after 20 years, one of the most exciting parts about surfing in the Great Lakes. I travel a lot to surf, and I open my Surfline app, and I've got every spot that I'm considering, the detailed forecast, the live stream, webcam, all that stuff, which is cool. Don't get me wrong, but here it's still like just this raw game of finding good waves in the Great Lakes, and it's still like that. Who knows if it will always be that way or not. I think it will be to a certain extent. It's challenging, but it's worth that. So once you start to get a sense of where to go, when to be there, what the conditions are going to be like, you have a choice. And this, again, takes a little time and experience, but it's what I call quality versus quantity. Quality to me means good wind conditions, a longer period swell like Ed was talking about. It doesn't have to be big necessarily, but just good conditions, and we'll kind of see that here in a second. But the coolest thing about surfing, you can do whatever the hell you want. I was telling a non-surfer this the other day. Somebody was interviewing me, and there's an old saying, only a surfer knows the feeling. And it's like, I played all the organized sports growing up, and I'm into all that stuff too, but surfing is just awesome because you can do whatever you want. You can surf whatever boards you want, you can surf whatever waves you want. There are no rules, you just do whatever you want. And on the best days, you can have quality conditions and quantity wave heights. That's the holy grail of lake surfing. So this is right here out in front of our store, our home beach, 2nd Street. These are both from last fall. It's what I call quality, right? So look at the surface conditions. You've got the guy on the paddleboard because it's nice and smooth, offshore wind, a longer period wave, longer period wave. Not huge, waist, ribcage high, but peeling nicely over the sandbar. We get these days, so like after 20 years of surfing, these are the days I'm still just clawing for and like waiting for. So that's what I consider quality, just good conditions. I don't care about the size. Quantity, still cool, right? That's a fun wave. We had a big day last Thursday, just 3 or 4 days ago. It was windy, it was big, it was just gnarly, there was a lot of water moving. So that's what I call kind of a quantity day. The surface conditions are blown out, it's like storm surf. We have a lot of those days in the Great Lakes because the conditions that we're surfing in are the same conditions that are building the waves, that are making the waves a lot of the time. And of course, some days you just have to take what you can get, The Holy Grail. So that wave is probably this big. The wind's offshore. It's perfect. That's on the north shore of Lake Superior. Lake Superior is the biggest lake. It's the deepest lake. They get probably the best waves in the Great Lakes. It's also cold as you know what. But it's beautiful.
Brian, what's the latitude and longitude of that spot?
All right. It's the North Shore of Lake Superior. It's not a secret. Okay, so the surf's here. You're going surfing. What do? Like I say here, hopefully you already have a sense of what's coming. You have a sense of where you might want to go. This is where you want to use these resources to get your real-time data, like your current data. Like Ed was talking about the buoy data. That stuff's crucial because, there's 24 hours a day. You've got work to do, you've got kids, you got whatever. It's like, okay, what's my time frame? What's it going to be like when I can go? Or if you're lucky, you can decide when to go. So using that real-time buoy data is crucial. And again, it takes a little practice, but it's not too difficult. The NDBC and the GLOS, Ed already referenced both those. Links are on our site. Here's the NDBC, the National Data Buoy Center. This is the go-to for me. I use both, but this is probably the first one I go to. Here's our James Bond buoy, 45007, which gives a good sense of what's happening over the entire south end of Lake Michigan. This one happens to show Lake Superior. So again, everything we're talking about today could be applied to any of these Great Lakes. But you want to learn how to use the data from these buoys and from the wind station. So I'll look at the buoy data to get a sense of the wave height, the wave period, the mean wave direction. So I kind of know what the wave is like out on the open water. But then I'll also kind of dig in to these weather stations on land to get a sense of what the wind is doing.
And those are obviously reading data all year round. So when the buoys are taken out of the water, your on-land weather stations are the next. And that is a different kind of forecasting because you don't have wave heights and period, but it's all we got. Yeah. So yeah, definitely the nearshore weather stations is the next thing for winter forecasting.
And here's the actual data that you get on one of the water buoys. This is again 45007. The wind direction, the wind speed, wind gusts, wave height. dominant wave period, average period, and the mean wave direction. Those are primarily the ones that I'm looking at. You know, the water temperature out in the open lake could be a lot different than it is near shore. But Ed referenced it earlier, that wave height, wave period, and the wave direction. So this is the gloss regional overlook. Ed showed a similar slide earlier. They're both good because this one has buoys that the NDVC site doesn't. So, you know, when there's actual swell happening or we're getting ready to surf, I'll check both. Here's the focused view of the gloss 45007. So this information should basically be the same as what you're seeing on the NDVC side because it's the same buoy. Although Ed pointed out to me that they read the wave heights.
Yeah,
a little
so
differently.
have you ever been on NDBC and you notice the wave heights read 1.6, 1.3, 1.62, 2.3, 2.6?
They're always fixed.
They're always fixed numbers. Has anyone noticed that if you looked at the buoy data? Well, if you start looking at it on NDBC, you'll notice that there's fixed numbers that are that's read off that information. But the gloss site will give you the raw, real data to the 10th of a foot, and it'll give you. Well, the 007 doesn't on this one, but you also get maximum wave height, which the significant wave height is what you're normally used to reading. But the maximum wave height will give you an idea on what potentially your every 15-20 minute sets are looking like. So you may have a 2.6 foot significant wave height, but your maximum wave height of the sets that come through every 15-20 minutes may be 4 feet. And sometimes people will make a decision, oh, 2.6, I'm not going. Oh, it's 4, okay, I'll go. Maximum wave height will be seen on the buoys on the gloss site, not NDBC. Just a little tidbit there.
Yeah, it's good to have both for reference for
Yeah.
sure. So we've kind of been talking about this, the variables that we're looking at, the wind direction, the wind and wave duration. The longer the wind blows and the higher, the stronger it blows, the bigger the waves are going to be, right? And then there's the fetch, which I think Ed talked about a little bit earlier. The fetch is the amount of open water that the wind is blowing over. So north to south on Lake Michigan is where we have the most fetch. So if you have a big wind blowing over a longer period of time, you're definitely looking at bigger waves. That's kind of the most basic way of thinking about this. And I know Ed talked about the wave period and the wave direction. Those are crucial. You know, that if you have a smaller wave height that has a longer wave period, you're looking at a more powerful wave versus a bigger wave height at a smaller period. We see in the Great Lakes, because our bodies of water are so much smaller than they are in the oceans, it's typical to see a bigger wave height but a smaller wave period. In somewhere like San Diego, it's typical to see a smaller wave height with a bigger wave period. And if you surf in either place, it's no secret that the smaller wave height at the bigger wave period is going to be more powerful than the bigger wave height at the smaller wave period. I'm confusing myself here. But hopefully you get the gist of that. Shows you how it shows you how well I know my own slideshow. So again, we'll post the video online, on Facebook, probably on our surf forecasting page on the website. We will find a way to get the PowerPoint presentations online.
Yeah.
We didn't do that last year, but I don't doubt that we can. So we're gonna do a little Q&A. We can start in-house, and then if there are any questions online, we'll go there. So does anybody have any questions for Ed and I? It's a lot of information, I know.
question.
Sure.
So, it seems like the waves are better in the colder weather. Is
Yeah.
that accurate? Am I misunderstanding?
No, it's definitely
Why
accurate.
would that be?
And it's really, it's simple why, because, and Ed can talk more about it than I can, but the colder the weather, the more active the weather systems, and the more wind that we see with those weather systems.
Yeah, so I mean, you just have you have two different jet streams meeting up during the winter time, where you got the subtropical jet stream, the polar jet stream, kind of coming together to form a big storm system. So you get large differences in temperature, which translates to greater differences in pressure, and bigger pressure difference over a smaller area, more wind. And also during the fall, I mean, the fall season is really the best time, because, I mean, Lake Michigan out there right now is still in the mid-60s. And in November, we'll get air that's 20 degrees moving over a lake that's 40 degrees warmer. And again, because the cold air sinks, that cold air digs into the water way better than warmer air does. So there's a much more efficient direct transfer of energy from the wind into water, as long as the air is colder than the warmer lake.
Yeah, so for me, if you think about our summers, the weather's nice, it's mild, it's not windy most of the time. Well, that's not good for surfing, right? Because we need wind to make waves. We do get waves in the summer, and we surf year round, and I actually love surfing in the summer. I may do it less, but it's warm, right? So I love that. But as we start to get colder, right now we're in early October, we're seeing it. I mean, today, you know, it went from 72 degrees on my thermometer this morning to 59 or something in the course of 6 hours. And sure enough, there were some waves out there this afternoon. And then you think about January, December, February. I mean, there's waves like almost daily during that time of the year, because we have these active weather systems just coming through consistently. So yes, in general, the colder the weather, the colder the season, the more consistent the surf.
And the other interesting thing is, in the winter, you know, if you've been to California, the kelp beds will oftentimes clean up the waves with an onshore wind, and that's what the ice sheets do out there sometimes. So you'll have the waves moving into you know, that you'll have open water near shore, but then out, you know, a couple miles off the lake, you'll have a massive ice sheet, and that ice sheet will clean up the waves real nicely. That acts just like a kelp bed.
It is pretty wild.
So even in onshore winds during the winter, you can have cleaner waves, because the ice sheets tend to clean up the surf, even with onshore winds. So.
What do you mean clean up the surf?
So the kelp beds in California tend to redistribute the energy of the wave more efficiently and over a wider period, and it actually cleans up the waves. It's a phenomenon that happens in Southern California, well, wherever the kelp beds are.
Yeah.
And here, if you have, you know, really blown out conditions over the middle part of the lake, once that wave energy gets to the ice sheets, that wave energy is pushed under, it spreads out, and when it comes out the other side, it comes out in nice rolling.
I like to think of it as a filter. Like,
Yeah, filter.
Like kelp beds act as a filter. So like in California.
Oh, Sherry, I mean, you live down there, you know exactly what I'm talking about. Yeah.
It's common for the wind to turn onshore, you know, by late morning or afternoon. But if you have a spot where the kelp beds are thicker, when that onshore wind is blowing these short period little wind chop waves, the kelp acts as a filter to kind of like just smooth it out, basically. So it stops the wind chop, but lets the swell roll through. And the ice, you know, it doesn't happen all the time, but it can for sure. The ice flows that we get offshore can actually do that. It's pretty wild.
It's colder than the kelp, but hey, if it's clean, we'll ride it.
Pier bounce. So I don't really know much about it. I just know that, you know, some people are all about the pier bounce.
Yeah, yeah, the rock pile gang,
Yeah.
Grand
But I
Haven.
I want to know more about like why.
Pier bounce
those
is-
types of waves.
It's a simple concept. You have two types of waves, I guess, that we surf in the Great Lakes. And we could talk a little bit about this. So here at St. Joe, we have our big piers that stick out. And when there's a north swell rolling down the lake from north to south, the piers act in a few different ways. They can actually cause, it's technically called reflection, I've learned. I always thought it was refraction. It's called reflection, but it's when a wave hits a fixed object and bends around it, okay? So you've got your pier sticking out here, you've got your wave or your swell coming down, it'll bend around it. So that's typically why in the Great Lakes we surf behind piers and jetties, because you get some reflection, some like wrap around the piers or the jetties. It also holds sand, so it can set up the sandbars better. And it blocks some of the wind and the wind chop, like the shorter period, like wind waves. So that's why I'd say the majority of the spots that we surf in the Great Lakes, there's either a pier or a jetty, or further up north we have points, bays, more natural fixed objects that can kind of act as the same way. So the pier bounce is the exact opposite. You're actually surfing on the windward side of a spot. And Grand Haven's the prime example for us on Lake Michigan, with a southwest wind, west-southwest wind. I would typically think about surfing on the leeward side of the pier or the jetty, so that means the opposite side of where the wave is coming from. But these guys that are surfing the pier bounce, they'll surf on the windward side, so the wind and the waves are coming from this direction. And there are certain angles that are better than others, but essentially the waves are hitting the pier, and then they bounce off the pier, they hit the next wave coming, so it creates like this kind of like washing machine effect. And if you get it on the right direction, and if the wind's favorable, it's kind of, it's what we call a peak. It gets peaky, so like it'll bounce back, and it'll peak up, and it could easily transform a wave this big into a wave this big. That's what pier bounce is. So it's like the waves bouncing off the pier. It's exactly like what it sounds like. Coming back, creating these like wedgy peaks, and
It's almost like a mini, wedge in Southern California that just doesn't look like it's anything. Then all of a sudden it just is
It's
this
the same
real
idea.
peaky huge wave that just really amplifies
It's
towards
also
the
called
towards the
constructive
shore.
interference.
Yeah,
There you
yeah.
go.
So you get these two waves that merge, and constructive interference. You get double the wave height.
Yeah.
That
yeah,
you
exactly.
just that you're seeing. So, and Ryan also mentioned he was talking about refraction. A longer period swell tends to refract more. So if I see, and I rarely see this, but occasionally we'll get a northeast swell 3 feet at 10 seconds. So normally a northeast swell, the North Pier here in St. Joe will block the swell, so you're not going to get any swell until maybe further south, way south of the piers.
Yeah.
But a northeast swell at 10 seconds, you have a wave that's pretty deep down into the water, and when you have refraction, the waves bend towards shallower water. That's exactly how point breaks work. So point breaks take advantage of longer period swell where you get this, screaming north swell, but yet you'll get really nice waves filling in along a beach that's facing south because the waves are refracting and bending around the point and coming toward shore. I mean, that's classic J Bay in South Africa, where you get, these huge waves from a north swell that just bend around like this because the period's so long. So I think the waves usually start feeling the bottom. I forget what
It's like 3.2 feet, I think. Or no, 3.2 times the height of the wave.
Yeah. No, I'm trying to remember it too. It's something that I think it's, so waves start, I have to look it up, but I think it's, I'll have to look it up.
But
before I start
Ed
talking.
talked about it a little bit earlier.
Yeah.
At a certain point, the energy, there's always energy below the wave that you see, right? And the longer period the wave, the more energy there is that goes deeper into the water. So at a certain point, that energy starts to feel the bottom. We haven't talked about that too much, but the bottom of the lake or the ocean is, you call it bathymetry, which is the geographic layout of the bottom. So here we have sand on the southern Lake Michigan shore. So you might have deep water offshore and then a sandbar and some deep water and then a sandbar. And you're kind of seeing the waves break. They break offshore, then they kind of gather back up. Then they hit that second sandbar because it's shallower. So the wave energy is feeling the sandbar, breaks again. You get a sense of what that is.
Yeah, so I think what we were talking about earlier, the wave starts to break. The actual wave starts to break when it enters water that's 1.3 times
1.3,
its wave height. So I knew there was a 3 in there. So we knew there was a 3 in there somewhere. But yeah, so when a 6 foot wave is going to start breaking in 8 feet of water. And here in St. Joe, you know, when you hear, you know, the National Weather Service, or you're looking at the point forecasts on the National Weather Service that are showing 15 to 20 foot waves, you're never going to see that breaking wave along the beach. That's happening out in the middle of the lake. So whenever a wave breaks, it loses height when it breaks again. So, the biggest waves I've probably seen here are maybe 6 to 8 feet, maybe.
Near shore, like surfing waves.
Yeah, near shore. The
Yeah.
biggest waves, and correct me if I'm wrong, write to me, tell me, but the biggest waves that I think would break on Lake Michigan are probably off of Point Betsy or Sable Point. Because you have the deepest water there. So the waves, as they're coming closer, aren't going to break. Anytime a wave breaks, it's going to lose some of its height by the time it actually breaks again towards the surf zone.
Yeah.
So your biggest waves, simply because the water just drops off so suddenly there, you're going to have your biggest breaking waves in the surf zone up across the northern end of Lake Michigan for that.
That's another reason why the waves on Lake Superior are typically bigger and more powerful, is because you're dealing not only with more fetch, with a bigger body of water, but deeper water.
Mhm.
So you don't have what's called shoaling like we do on southern Lake Michigan. Shoaling basically means that it's breaking further offshore. So on the north shore of Lake Superior, it's hundreds of feet deep right up until the shoreline, basically. And then it gradually, and this is the case for a lot of, ocean breaks, especially big wave breaks like Mavericks in California or Nazar in Portugal, or, take your pick. You've got deeper water suddenly converging with shallower water. So you've got these, the wave energy is not dissipating or going away until it actually hits that shallower bottom and breaks. And that's why a wave like Mavericks in California is so intense, because it's coming out of deep water and then boom, it suddenly hits the reef and
Chopu. Yeah, 20-foot wave will break at the reef there. It'll break so much, lose so much of its energy, you're just looking at a 2-foot wave at the immediate shore, away from the reef.
inside the reef.
Yeah, inside the reef.
Any other questions?
What's the HRR stand for?
Okay, yeah, so
And where do you find that?
I didn't get into that much. So
Oh, okay.
the HRRR, if you type in NOAA, HRRR, you'll get to the site that shows you, that gives you the HRRR data, but it's hard to navigate. I mean, I go to the site and I still have trouble navigating. So if you message me on my page or Third Coast Surf Shop, I can explain how to get it there and actually post links. But the HRRR stands for High Resolution Rapid Refresh. Again, goes out 18 hours, updated 24 hours a day on the hour. Gives you very high resolution wind data, direction, speed. I mean, that's how I'm nailing down the timing of the front. What happened? Oh, okay. It get dark. Do I need to stop talking? So the GFS, which again, your default Wind Finder app is going to use the GFS data if you don't have it. You can actually use Wind Finder and pay Wind Finder to give you more high resolution model data, but the high resolution model data, the HRRR, that's going to give you your real high resolution model data within a very short amount of time, going out 6 to 8 hours if you're trying to time that wind direction. Because here on the Great Lakes, you're looking, when are we going to see that 180 degree wind switch.
Yeah.
Well, the GFS isn't going to tell you that. The wind finder isn't going to tell you that by default. You have to make sure you're looking at high resolution model data, which is available for free, and I can show you how to get to that on the Dr. Fresh page.
Any online questions, Erin, by any chance?
Yeah, actually, Great Lakes Surfers Journal, from
Okay.
Brian there.
Brian Tanis.
Yeah, he's
Hi,
actually.
Brian.
Yeah. He's in Romania right now. He's
Okay.
looking at surfing the Black Sea tomorrow.
Okay.
Yeah, so he asked if it's true that anywhere on the Great Lakes can be surfable.
Can anywhere on the, yeah.
Everywhere.
People have surfed Lake Tahoe, Brian.
Yeah.
So.
Devil's Lake, somebody I know has surfed Devil's Lake, North Dakota, which is a lake that's growing. It's becoming a huge problem for farmers. But the lake is big enough where you have enough fetch, you can get big enough waves. So
Yeah, you can surf all 5 of the Great Lakes.
I haven't seen too many pictures from Lake St. Clair.
Right,
But-
is that technically a Great Lake?
Yeah, I would imagine it's at least as big or bigger than Tahoe, so I'm assuming you can.
Oh, you can,
I just
yeah,
haven't.
for sure.
I just haven't seen pictures.
The smaller the body of the water, the less good the surf is going to
Yeah.
be. It's basically
Although
what it
I've seen
comes down
I have seen clean conditions on Lake Tahoe.
to. Really? Get the wind switch.
Yeah.
Go
last,
snowboarding.
last 5 minutes
Yeah,
before
right,
it fades.
Yeah.
But yeah, it happens.
Okay, another one from Brian. Are there secondary swells? I'm not sure if we covered that. in the-
Well, actually, yeah. The other day, so we had a north. So the other day, Wednesday night, we had a huge south on Wednesday. Turned to southwest, then west overnight into Thursday morning, and then the wind Thursday morning turned to hard north and blew all day out of the north. But much of Thursday, we had a north swell mixing with a secondary west swell, which is why that north swell was a little bit junkier than I thought it was a little bit junkier than we're typically used to with
Yeah,
with the
it
north.
was so windy, it was kind of hard to tell.
Right. So when you really want the ideal swell in the Great Lakes, you don't want any strong south or strong west. You just want to start blowing strong out of the north from a previously calm lake, because if you have a strong west or you have a strong southwest, that's going to be mixing in with the north. That's eventually the main entree. And on the Great Lakes, most of the time a lot of the times you don't have a really annoying secondary swell or third swell like the ocean. That's why that's one aspect where the Great Lakes are better, because you're normally just dealing with one swell direction. But yeah, Thursday was a perfect example where when we were surfing out there, there would be a really nice, you could tell where the north swell was, but then out ahead of the really nice wave was this other wave coming from a different direction that was kind of making the wave real broad, and it was hard to paddle into.
There are some spots in ocean locales where a secondary swell can be a good thing, like a
right.
combo swell.
Yeah, sure, for sure.
But that's like very specific to certain spots.
Right, right.
In general, though, it's probably not a good thing.
Yeah, it's caused more issues than it being a good thing. But yeah, occasionally, we do get, secondary, even a third. On Wave Watch, and this is another thing I can show you, you can actually track all of the different swells that will be forming from a wind event.
Really?
Yeah,
Nice.
yeah, so there's a Wave Watch bulletin where you can click on the buoy and it'll show you all the swells that'll be going on at any one time. But yeah, it's hard to navigate to, but I can kind of show you that
That's cool.
on the page. on
Any other
Facebook.
questions?
Oh, we have one more from Facebook actually. This one's from Keenan Kamalani Kamei, and he's in Tokyo.
Okay.
Yeah, so hello. And he asked about isobars. What exactly do they indicate? And he asked about when reading a weather map, he learned what you shared earlier, that the wind direction is often not parallel to the isobars.
Okay, yeah, so isobars are lines of equal pressure. Most of the time when you're looking at a surface map, you'll see a high, you'll see a low, and you'll see all these lines wrapping around the high or low. Isobars, iso meaning same, bar, barometric meaning pressure, isobar, lines of equal pressure. Typically, we don't, theoretically, winds blow exactly parallel to the isobars, but because of friction, that's not what we typically see. So the winds always blow at an angle. With a strengthening area of low pressure, your winds blow more of an angle to the isobars. With a weakening area of low pressure, your winds blow more parallel to the isobars. So it depends on how fast or whether the low is strengthening or weakening. But the wind, the theoretical wind that blows parallel to the isobars is called geostrophic, which a term you might have run into, but most of the time we don't see the geostrophic wind because of friction, which causes the wind to always blow at some angle to the isobars. But it roughly blows counterclockwise around low and clockwise around high in the northern hemisphere, opposite the southern hemisphere.
Do you think when we look at some of the wind models, do you think those match up with parallel with the isobars, or do you think
No,
they're
usually,
gauging-
yeah. So usually, if I look at the high resolution model, the HRRR that Sherry was asking about, that does a really good job of showing that component of the wind that actually blows more at an angle.
Mm.
So
what about like I-wind surf or sail flow?
yeah, so if you overlay the surface wind on top of the isobars, you'll see that the surface wind actually crosses the isobars. And the reason is because we've got friction involved, which
Wow,
causes
so the models actually take that into
oh yeah,
consideration.
and that's a big one. I mean, the models can't miss that. I mean, that's and sometimes in your strongest areas of low pressure, the wind will actually blow perpendicular to the isobars.
Oh wow,
And to a surfer who thinks it's going to be blowing parallel, you're dealing with a 90-degree
it's a lot.
change in wind direction. So you're going to show up there surprised,
Right.
not knowing what's going on. But that's typically with a strengthening area of low pressure, it's going to blow more at an angle to the isobar.
Yeah, interesting.
Oh, a couple more good questions from Facebook. From Ryan, how has water level played an impact on spots and swell?
That's a good question. It definitely has. What I've learned is that typically, at least on Lake Michigan and Lake Huron, because they're technically connected, it's a 30-year cycle, high to low. But with our changing climate, that seems to be out the window. When I started in 1998, it was high. Just a handful of years ago, it was at record lows. And then last year, it was back up towards record highs. So the whole 30-year thing, I don't know, in my experience, it seems to be changing a lot faster than that. Evaporation, from what I've learned, is the biggest factor. So if we don't have ice on the Great Lakes in the winter, you get more evaporation and you lose more water. The levels go lower. If you have a bigger winter, more ice, keeping the water in the lakes, it tends to stay more stable. Obviously, there are a lot of other factors involved in the lake levels, but on the ground level, the surf spots that we're surfing, I've surfed in a lot of different places all over the Great Lakes, and you can see it. I mean, you can definitely see the waves change at some spot, at most spots, really. In a place like here in St. Joe, it affects it somewhat, but because our beach is pretty stable, it's more about just like how big the beach is versus how the water levels are affecting the way the wave breaks. Because you do have shoaling on southern Lake Michigan, you've got this gradual steepening of the bathymetry, the sand on the bottom of the lake. But then you go up north to some of the points and the reefs, stuff like that, and it's way more pronounced because you have less shoaling, and you can see, on higher water levels, the wave is breaking differently than it is on lower water levels. And it's different all across the lakes. I was in Sheboygan. Aaron and I took the boys to Sheboygan last fall. Just a great place to surf. Super cool people, great waves. There's a spot there that at lower water levels a handful of years ago was just firing. Like it was breaking like a point. And it was super good. And then we went back last year and I checked it with these higher water levels, and it was not even there. Like there wasn't even a wave breaking really. So yes, the water levels have definitely affected the way waves break at different spots.
Yeah, when I surfed on Lake Erie, my favorite. I had a really great spot in Pennsylvania, and it doesn't work anymore because water levels over there are higher. So, you know, even a water change of a half of a foot or a foot or a foot and a half can be significant in wave quality, especially if you have an area where you don't have sandbars that can change, like a limestone reef could be permanently changed.
Yeah.
Because of, I know there's a lot of those on the Wisconsin side. With the limestone reef, you're not necessarily going to get beach erosion. The water level's higher, and the limestone's fixed, so you're looking at a break that's permanently damaged until the water levels drop.
Yeah, exactly.
So.
Oh, let's see, another good question, let's see if I can find it. Oh, a good one from Michael. How come New Buffalo doesn't seem to go up on a north like 5 years ago?
Good question. You know, it's pretty specific about that spot. I've been surfing New Buffalo for a long time, and the water levels, you know, we were just talking about it. New Buffalo is a good example of a place where the water levels have really affected how the wave breaks. You know, it's with the deeper water, it just hasn't seemed to be as good as it was with lower water. A lot of that too. I mean, the water levels definitely play a factor, but also the way the sand moves. Dredging can play a factor. You know, when they dredge the harbor mouths, where they dump the water. So there are definitely different variables that go into how any break can work, but. I've heard New Buffalo has been good this summer, so Michael, you might want to give it another try. I haven't seen it myself yet, so take that with a grain of salt. Any other questions?
I think that's it from social media.
Cool.
Yeah.
Any more in-house?
Oh, we did get a question about your shirt, and that is available online. It's called the Dapper Puss.
The Dapper Puss.
Yeah.
It's the octopus smoking a pipe. I don't know what's in that pipe, but something. All right, well, thanks for coming, everybody. Really appreciate it. Thanks for everybody watching online. Like I said, we'll post this online on Facebook. We'll get it on our website. We'll get the PowerPoint in both places too. And I hope you learned something tonight. I hope you didn't, I don't know, was it too much? Was it a good amount?
Oh, yes.
Cool.
Very nice.
All right, thank you guys.
Thank you.
Thank
Thanks
you.
for coming.